In this section, we're going to talk about the 5-number summary and box plots. But before we get into both of those items, we kind of need to discuss outliers. I don't believe we've discussed that up until now, so let's formally kind of define an outlier for us. Outliers are those values in a data set that are very far outside of where we would expect the data to fall. That can come from either data entry, it could be a mistake, or it could be just really large or really small numbers. So let's look at an example of a data set that I have that's going to illustrate outliers for us. Here's a data set for my class survey that I give to students where I ask the students to enter in their height in inches. And if I were to take this column here, which is the left column, and I order the column from smallest to greatest, notice what happened. In the column here, all of a sudden, I have a data entry of 5, 5.3, as well as 6.2. And I can tell you right now that those values are incorrect because there's not anybody alive that is 5 inches tall. In fact, when my children were born, they were 17 inches long. So it's unreasonable to think that we have heights at 5, 5.3, and 6.2 inches. I would hazard a guess that the 5 is 5 feet as opposed to 5 inches, as well as the 5.3, maybe 5 feet 3 inches, and 6 foot 2 inches. Sometimes I've even seen values such as this 59 here, where that value might be 59 inches. Rarely do I have someone who is 4 foot 11 inches tall, but that does happen sometimes. I'm 5 feet tall, but that's how come I can measure kind of relative to my height if people are shorter than me. More often than not, however, if I have entries like this, it's going to be another variation of, say, 5 foot 9. So these types of values, specifically the 5, the 5.3, and the 6.2, are values that appear to be an incorrect input. And if that's the case, then they're going to show up for us as outliers in the data set. So let's see if we can figure out how to construct a box plot by using the 5-number summary that we are about to define. Here we see the example we have seen previously for our Old Faithful Geyser data set. And in here are our 5-number summary data points. We start with the min of our data point, Q1, the median, Q3, and the max. All 5 of those values, the minimum value of the data set, the Q1, the median, the Q3, and the max, are considered the 5-number summary in a data set, and we're going to use those numbers to construct a box plot for our height data set. Now here are the directions that we're going to use to construct it by hand. First, we have to draw a number line, if you will. Then we're going to label our quartiles Q1, the median, and Q3. From that, we're going to draw fences. Now, the fences are used for us to help identify those outliers that we might encounter in a data set, and the calculation for the fences is given here. We're going to take 1.5 times that IQR, which is our inner quartile range, and we either add it to the Q3 value or we subtract it from Q1. So we're going to construct by hand a box plot here on this screen using our data set for height in inches. In StatCrunch, I'm going to use StatCrunch's capability to find the 5-number summary. So let's go Stat, Summary Stats, Columns. I'm going to do this for the height in inches column, and down here in the statistics box, we're going to select those values from our 5-number summary. So we need to select the minimum value first, hold Control down, select Q1, then we've got the median, Q3, the max, and I'm going to add to this the IQR to help make our calculations go faster. So I added the IQR to this box. I'm going to hit compute, and these are the values that I need: the min Q1, the median Q3, the max, and the IQR to sketch my box plot. So we're going to start with our number line. The number line is just a line representing our data. So the minimum value in that number line should be 5, so that's my min. And then the maximum value on this data set is occurring at 76. The next thing that we're going to put on our construction here is going to be Q1, the median, and Q3. So I'm going to start with the median. The median is at 65, and I'll tell you right now, I'm not trying to draw this to scale, so let's just put 65 here. So this is 65.5. That was our median value. To the left of the median is Q2. That occurred at 62, not Q2, excuse me. To the left is Q1. To the right of the median is Q3, and that was at 69. So for these lines I've drawn, I'm now going to connect them as a box. So here is our box consisting of a left edge of Q1 and a right edge of Q3. The next thing I need to construct are the fences. So there's a little bit of a calculation that I need to do for the fences. You see down here in my screen, we're going to take our Q1 value, which is 62. We're going to subtract 1.5 times my IQR, which we found in StatCrunch to be 7. And then we're going to take our Q3 value of 69 and add 1.5 times that 7. So making those calculations using my calculator, I find that I have a lower fence that's going to extend down to 51.5. So let's move that right here. This is our lower fence at 51.5. And I'm going to draw a line that connects the box to the fence. My upper fence is going to go all the way to 79.5. However, the largest number in my data set is 76, so my upper fence is the maximum value, which is occurring here. So if your upper fence or your lower fence goes outside of your max or min, you end at the max or min. So this is how you construct a box plot. What we would see then is, remember those 3 values that we saw when I ordered our data set in StatCrunch? We had extra values that occurred here at 5, 5.2, or 5.9 and 6.2. Those 3 values occur outside of my lower fence and are therefore denoted or show up in a box plot and allow us to easily identify those outliers when we construct fences. So our 5 number summary consists of the min, Q1, the median, Q3, and the max. And then the fences are constructed using this formula and multiplying by the IQR. This is how you can construct a box plot by hand, but we'll be using technology to construct it in the future.